Good morning, my dear students. Welcome to the world of physics. We were discussing about electrical current, and the last day we have discussed about the sources of electricity. So, the last portion of our class today we are going to discuss about electrical circuit and circuit diagrams. So, what is electrical circuit, or what is the circuit diagrams? An electric circuit can be defined as it is a closed path through which electric current can flow. It is a closed path through which electric current can flow. That means when suppose we are having so many devices we are using in our home, or there are so many other devices what we are using, or even in the experiment we used to connect. The basic requirement for the flow of current is that there should be, as I said, that there should be a potential difference, there should be negative and positive terminal should be there, and it should be closed circuit. That means there should not be any break, any broken piece or any broken of this conducting wire in between this potential difference, positive and negative terminal. As we know that when we are discussing about, already we know what is cell and what is battery, and when we have discussed about dry cell we have seen that the dry cell cannot work by itself when it is connected with a wire from positive terminal to the negative terminal, and on the wire if you are connecting a bulb, then what will happen? The bulb is going to burn, that means the cell will start working. So simply we can say that when we are speaking about, suppose I want to connect a bulb and I want to connect a switch and a cell. So how I will be diagrammatically, how can I represent that? So this is how I can represent this. There is a cell is there. Cell is I have already defined as a cell, or I have known as a cell. A key I have given here. Then a bulb is shown and it is connected to from the positive terminal, it is going to the switch and it is going to the one terminal of the bulb, then another terminal is coming and it is coming to the negative terminal of the bulb. So this is a closed circuit. This is the closed circuit. When it will be open circuit, whether if the switch is or the key is not put, key is open, then we can say that it is an open circuit. Or even though the key is closed but somewhere the wire is broken, then we can consider that it's an open circuit. And open circuit, there will not be flow of any electricity. There will not be flow of any electricity. So the requirement for the closed circuit is that from the positive terminal to the negative terminal there should be conducting wires should be there, and if the devices should be connected in a proper way, and there should not be any breaking for this line. The line should be fully closed, then we can say that it is a closed circuit, electrical circuit. And when it is, the switch is off, or when the switch is open, or in between somewhere if the wire is broken, then we can call them as an open circuit. Clear? Okay. Now again we are going to discuss more about the electrical circuits. Okay. So a simple electric circuit consists of some basic requirement. It needs some basic requirement. Initially, there should be a source of electricity. Yesterday, we have discussed about sources of electricity. So, there should be one source of electricity. What will be the source of electricity? The source of electricity is an electric cell. Then, next one is what we need? We need an electrical device. For example, a bulb is an electrical device. An electric bell is an electrical device. So, one device should be there. And the last one is that a switch should be there. Surely, a switch should be there in order to control the device. And the final one is there should be a conducting wire. What is conducting wire? The material which can conduct electricity. That means the copper, normally we are using copper wire, gold is there, or the aluminum is there, silver is there, all these are conducting things. And among this one, the copper is very cheaper, so for the wiring and all we are using copper wires. So there should be a conducting wire should be there. So what are the requirements? A source of electricity, that is a cell, a device, that is bulb, example as a bulb, a switch and a conducting wire. All these should be connected properly, then we can call them as a closed circuit. Okay, now again we can look at your textbook page number 93. There it is shown. Okay, the first figure 7.12. 7.12 you can see that it is connected in such a way. Now, you just imagine that always we will not be able to draw this bulb or this cell, switch, etc. as it is. It will take so much time and it's very difficult to draw also. So these cases we will use some symbols. Instead of this bulb, we will use the symbol of a bulb. Instead of a cell, we will be using the symbol of a cell. Instead of a switch, we will be using the symbol of a switch. So what are the symbols? These are shown there. This is the symbol of a cell. How we will be just making the cell like this one, big line and small line. It will be connected. This is negative terminal and this is positive terminal. So this is a cell I have shown there. And what is the battery? Connection of more than one cell is called battery. So I can show that there are two cells are there called battery. And normally we are having ammeter, voltmeter, galvanometer. Ammeter will give the amount of current passing through is, and voltmeter will measure the voltage of that circuit, and galvanometer will give the direction of the current. That means from where to where the current is flowing. And electric bulb, the symbol of electric bulb is from that bulb, we can use this one. Then open switch means it is open or there will be a dot. This is called the open switch. That means switch is at a off position. Then this is closed switch or switch is at a on position. Switch is at a on position. Okay, and the last one is resistor. That last symbol is for a resistor. We will discuss the last topic of this today. What is resistor we are going to discuss. So these are the symbols of the electrical circuit what we are using instead of the instruments. Okay, now how can we draw this one using this symbol? So here I am having a cell. So here this is positive and negative terminal. So I am just taking this one. So this is negative, maybe this is positive terminal. I have one. Okay, whatever. So I am going to draw the cell. This is negative terminal. This is positive terminal. Okay, and the cell is going to connect with the key or switch. A switch I have given, and then connecting wires, bulb. So this is known as electrical circuit, and the flow of current will be from always from the positive terminal to the negative terminal. So it's clear now. This is called electric circuits. Okay, so what is electric circuit? How we can define it? Circuit diagram. So it is very difficult to draw the actual components of an electric circuit. The arrangement of electric component is generally shown by the symbols. When we are using the arrangement of components using the symbol, then it's called the circuit diagrams. Electric circuit diagrams. Okay, so this is what we are using in our all the field of electronics. Electronics is one of the main branches of physics. So in electronics, if you are after the degree or during the degree and the PG, and if you opt for electronics, we will be dealing with this electrical circuit diagram. This is the simplest one. The very difficult circuit diagrams are there. That means whatever be the electrical devices, from the smallest device to the supercomputers also, there are electric circuit diagrams are there. Also, it's very, very important. Now, we are moving to the next one. So always, whatever be the electrical circuit diagrams, always the current will be flowing in which direction? From the positive terminal to the negative terminal. From the positive terminal to the negative terminal. Now we are going to study about closed and open circuit. Already we have discussed what is a closed circuit. When all the components are connected together without any breakage is called closed circuits, or the switch is in on position. What is open circuit? When these are not connected properly, or when the switch is off position is called open circuit. And closed circuit only will work. Open circuit, there will not be any flow of current, so the device is not going to work when the circuit is open. Now we can connect that means this electrical circuit diagrams or the connection of electrical components are of two types. One is parallel circuit and another one is series circuit. So two ways we are able to connect the components in the electrical circuit. Okay, so first we are going to discuss about series circuit. But how we are going to connect the material objects like with the components using a series circuit. Okay, in a series circuit, each device is connected in such a manner that there is only one path through which the electric current can flow. In series circuit, we are going to connect the devices or the components in such a manner that there should be only one path is there for the electrical current to flow. Okay, so how we are going to connect here? See, here I have a cell here, a key or switch is there. Then one bulb V1 is there, bulb V2 is there. What will be the direction from the positive to the negative? So this will be the direction of the current flowing. Now, when the key is closed, the current will start flowing. Is it now? Here you can see only one path is there for the flow of current. Only one path. Okay, so if there is any breakage in this line, then suddenly what will happen? There will not be any flow. Or if one of the device is not working, that means if the bulb V2 is fused, then what will happen? V1 also will not work. Fuse means it's broken. It will become an open circuit. Okay, now this is called a series connection. One activity is given on page number 94. You can see that there are two bulbs are connected with a battery. That means a cell. Already I have shown here. And the first this is saying that if there is a closed circuit, then only it will be working. The series connection. So what is the problem here? If the key is open, both bulbs will not work. If the key is closed, both bulbs will start working. That means they cannot work independently. That means once the key is on, when the current is flowing, all the components which are connected in a series connection will be working. Okay, now again the second one is that if there is any breakage in this line, then what will happen? All the components are going to be turned off. Okay, so we cannot control one by one, we can control all the components or all the devices together. Okay, so that is the problem for series circuits. Then what are the conclusion from this activity? First one, all the devices work simultaneously. When the switch is closed, also all the devices will stop together when the switch is open. Then, if any of the device is out of order, all others also will stop working. That means if any one bulb is getting used, the other bulb is also not going to work. Sometimes nowadays we have advanced with even though when the Diwali and all comes, we used to buy the series bulbs to decorate our homes and all. Then you can see that sometimes these bulbs are arranged in series. If it is in series, if one bulb is getting fused or one is not working, the entire series is not going to work. If it is connected series. So instead of that one, nowadays we are using parallel connection. That means 3 wires will be there. Common wires, common connection will be given to all the devices. That we are coming to study. Then the last one is same current flows through all the devices, and if one device is not working, it results in an open circuit. Open circuit will not work. Then again we can study something about this one. It is given on page number 95. Series circuits are of an advantage when you want to be if any one of the components stops working. That means in series, if we are using series connection, what is the benefit? If one bulb is not working, we can identify. That means the entire system is going to. We will get a warning that entire bulb, the things are not working, so we have to find. It is very difficult to find, but we can find. And for the series connection, the wire required is very less. So economically, we can say that the series connections are very cheaper. Okay, so this is about the series connection. Then again, the next connection is parallel circuits. Parallel circuit. So what is parallel circuit? So parallel circuit means what? Here we were giving only one path. In parallel circuit, we are going to give different path for different components. If there are so many number of components, if there are 3 bulbs are there, then we will give 3 separate connections for each bulb. Okay, or if there are 2 bulbs are there, we will give each separate connection. So I have shown this one. Yes, is here. positive and negative terminals are there. Its connection is given to a common point of positive and negative. So from a common point, I have taken one connection to bulb B1 given switch 1, and the another one from the common bulb B2 and switch 2 I have given. So what is the benefit of this one? That both the devices is going to work separately, that means independently. If S1 is switch 1 is on, only the bulb the B1 is going to work. And the switch 2 is on, then only the bulb B2 will work. So we are able to control the devices or the components separately. What we need, that we can make them to work, and what we do not need, no need to work. Then the next one is that if one bulb is fused, one component is not working, the other component will work. Since it is parallel connection, the other component is going to work. So this is the benefit. This is called a parallel circuit. Parallel circuit. Okay, so activity 3 is there. You can read the word. That is this only. What is that? We are given a common connection. Common connection is there. Each one component has given the separate connection. For example, in our home, we are doing the parallel connection during the wiring. Why? If it is series connection, there should be only in your room, there will be only one switch. If you switch on, fan will be working, bulbs will be working. If there is TV will be working, AC will be working. All the devices will be working together in series connection. And if one is getting fused or one is getting damaged, no device is going to work. And we do not know where is that. That means if it is not working, we do not know whether the fan is got a complaint or whether the AC is got complaint or the TV is got complaint. We have to check all the devices. Okay, but if we are connecting in parallel, we are connecting normally in parallel. If we need bulb, then there will be a separate switch board. That's why we are having in our room there are so many number of switches. Each device is given separate connection and separate switches. So what will happen? Each device is going to work independently. That means if you need bulb, you can switch on the bulb. If you need the fan, you can switch on the fan. And if you don't want the fan, you are able to switch off. If it is in series, there is only one switch. If you switch off the fan, the bulb also will be automatically switching off. If it is in parallel, if you don't want fan, you can switch off the fan, but the bulb will be working. This is the benefit. And another thing is that if there is one thing, that means fan is getting complaint, means when we are switching on the fan will not work, the other materials will be working. So very easily we can find out which device is that got damaged and we can repair it very fastly. That's why we are using parallel connection in our home wiring, and all the devices normally we are using a parallel connection. Okay, and we know that for the parallel connection we need a more amount of wire now. That means here we need only this much wire. Here one is given to bulb 1, one is given to the bulb 2, and if there is one more there, then bulb 3 switch separately. So this is going to increase the cost. This is going to increase the cost of wiring, but this is the good method or the best method for wiring. And again, what are the benefits of this parallel circuits? The various devices can function independently. Any device can be switched on or off as desired without affecting the working of other devices. That is what the main benefit. All the devices will be working independently. Any devices can be connected with a separate wire, with a separate switch, and we are able to control the devices separately. Then the next one is that if any of the devices is out of order, the other devices continue to work. Okay, any one device is mistake means and other things will be working. And each appliance gets through electrical energy and so works its full capacity. That means in series connection, the bulb one will get the electrical energy, and remaining one only will be given to the bulb 2. Sometimes first one will be brighter and second one will be less bright. Here, all the devices are getting the current equally, so they can work to the maximum capacity. Now, the last portion, 2 portions are there. Electrical resistance. What is electrical resistance? What do you mean by resistance? The word resist means what? To oppose. Resist means to oppose. Suppose we know that already we have seen that how the electricity is flowing. Electricity is flowing through the conductors very fastly from one end to the another end. And we know that there are a boundary for the container. If the wire is having a wall, a container, the boundary is there. So when these electrical device charges are flowing from one end to the other end, they may collide with each other, or they may collide on the sides of the wall of the wire. At that time, what will happen? Their speed is going to slow down and they will come and struck. And already we have studied in the chapter friction, when one object is moving, that means there should be an automatically opposing force is called friction will be originated. So this opposing force is called resistance. The property of a material due to which it opposes the flow of current through it is known as resistance. What is resistance? The property of a material due to which it opposes the flow of current through it is called resistance. Okay, so when this colliding happens, that means depending upon the level of nature of material and different substances offer different resistance and can be classified as conductors and insulators. So depending on the property of resistance, what is resistance? The capacity or the property of a material due to which it opposes the flow of current through it is called resistance. Due to this property of resistance, we are going to divide the materials into two categories, which are the conductors and insulators. Which are the conductors and insulators. Conductors are the devices. Conductors are the devices or the materials which are going to offer less amount of resistance. That means the current can be passed very fastly. Whereas insulators are the materials which give the maximum resistance. That means the current sometimes cannot pass. Okay, so the materials around the world we are going to classify into two categories depending upon the resistance. Conductors and insulators. Conductors means what? The material that allows the current to pass easily is called the conductors. These conductors are offering very low resistance to flow the electric current through them. All the metals and impure water and salt solution are example of good conductors of electricity. And graphite, a non-metal, is also good conductor of electricity. And the next one is called insulators. What are the insulators? Materials that do not allow electric current to flow them are called bad conductors or called insulators. They are offering the maximum resistance. So the flow of electric current through them it will be very difficult to flow. Dry wood, glass, rubber, plastic, okay, bakelite, and are some examples of insulators. Some common examples of conductors and insulators are given in page number 96. Silver, that means conductors are given, insulators are given, that you have to study. Okay, then there are certain substances that offer appreciable resistance to flow the electric current through them. Such materials are called resistors. A resistor regulates the flow of electric current through a circuit. That means sometimes when we are creating an electric circuit, we don't want to send that much amount of current at a particular time. So how we can control the current? By adding resistance, by increasing the resistance in the conducting wire. Conducting wire means it's very less resistance only, but we are able to increase the resistance. How? By installing resistor. In page number 96, I think in figure 7.20, you can see that some resistors. If you open some electronic devices, you can see the resistors. What is the function of a resistor? To control the current which is flowing through a electrical circuit. Okay, so the resistor regulates the flow of electric current through a circuit. Tungsten, constant, and nichrome are typical resistors. This is why we use of making heating elements for heaters, toasters, electrical irons, etc. That means some things are which is having more resistance. If there is more resistance, what will happen? If the resistance is more than what will happen, it is going to get heated also. The heaters we are using this one. So this is about our today's portion. What all things we have discussed? We have discussed about electrical circuits and circuit diagrams. In that we have seen that how we can represent it diagrammatically, and we have studied about the symbols of the components, and using symbol we have redrawn this one, and this is called electric circuit diagrams. And electric circuit diagrams are of two types: series connection and parallel connection. Parallel electrical circuits. Series means only one path for the current to flow, but all the components will be working depend on each other. If one is not working, no one is going to work, and can be given only one common switch. We are able to control only all the devices together. We will not be able to control separately. Whereas parallel connection means we are going to give separate connection and switches for the separate components, so that what we require will be working. Then we have studied about electrical resistance, the property of a material due to which it opposes the flow of electric current is called resistance. Depending upon the property of resistance, we have seen, or we have divided the materials into two categories: conductors, insulators and resistors. Conductors is having very low resistance, it will conduct the electricity very fast. Insulators are having the resistance maximum and are conducting very difficult. And resistors are there, that means they are called appreciable resistance. That means they will regulate the flow of current in a circuit. That means we are able to control the circuit by installing the resistors. Okay, so this is about our chapter, and we have completed the syllabus. So what you have to do is you have to complete the study questions and exercise portion, and if there is any doubt you can contact me. Thank you.